Okay, so now we have exercises to correct. These exercises are supposed to be delivered before this video, so you can correct yourself your own mistakes. I'm going to correct the first three exercises. I have it here already, the solutions. I will upload the solutions anyway, but I'm going to explain it and go each by each. Okay, so we have in the first one, we have this compound, okay? So the first thing we need to recognize is the oxygen, okay? Well, first of all, we have here in bold the different names of the compounds, okay? This is what you had in the exercise, and then in cursiva we have these answers. Okay, so in the first exercise we have oxygen and gold. Okay, gold. So in the stock nomenclature, we name with prefixes. Okay, so we have 2 golds and 3 oxygens, because all these are talking about, all this exercise is talking about oxides. So this is a clue about the name we're going to use in the stock. So in this case, all of them are going to finish in oxide, 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 and oxide. All of them. Oxide, 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 and oxide. Okay? So then we have 2 golds using prefixes will be D gold, and then 3 oxygens, 3 oxide. Okay? Stock nomenclature is the easiest one. We have then systematic, and we're going to use Roman numbers to describe or to make known that the element before the number, is going to use this number as an oxidation number. Okay, so why we put 3 here is because gold has 3 as an oxidation number. Okay, 3. And oxygen, all the time, like always, oxygen has 2 as an oxidation number. Okay, and then we swift. I will write it here and then I will erase it. We have this compound. Yes, sorry about my handwriting. So we have gold and 3 oxygens, 2 gold and 3 oxygens. Why we can put here, because this oxygen has -2 as an oxidation number and +3 as an oxidation number of oxygen. Okay, and then we gold, sorry, and then we swift. Oxidation number of gold goes to the index of oxygen, and oxidation number of oxygen goes besides a side of gold. Okay, so that's why we have D gold and then 3 oxide, 3 oxygens. Okay, good. The next is this. This is the name we have, and then we have to know what is the formula of the compound and the systematic name using oxidation numbers in Roman names. So Roman numbers. So the iron trioxide, is very easy because we can know that iron has a 2, the iron, and then 3 oxygens, 3 oxide. Okay, very easy, very easy. All of the compounds, as you can see here, all of the oxides, all of them, all of the oxides have the same structure. First the element and then the oxygen. Okay, so knowing that these two comes from the oxidation number of oxygen, yes, and these 3 comes from the oxidation number of iron. That's it. So when we write systematic, we have to say iron and then the oxidation number 3. Yes, not 2, even though here is the iron. Here we need to put the oxidation number used by I'm writing here in the bottom. So oxygen have 2 plus, 3, and the oxygen -2. We shift, we write here 2 and here a 3. Yes, that's it. Good. So we have done this exercise. Next, what do we have? We have this name. Yes, lead 4 oxide. So lead will be Pb and oxide. Yes, because they're telling me that Pb is 4, and I know that oxygen has -2. This 4 will go close to the oxygen, and this Pb will go close to this -2 will go close to the lead. Okay, so since we know that we need to divide by 2, okay, we will have to divide Pb2 by 2, which is 1 here, we don't write it, and the O4 divided by 2 is O2, is here, okay, is here, okay, yes, Pb1, we don't write it, but we write 2, and we keep it there. So now that we have the formula of the compound PbO2, it's easy to get the stock name, lead dioxide. Okay, dioxide. I will choose another color. Dioxide. Okay, dioxide. Good. In the next exercise, we have this compound here, this compound, and we need to get the stock nomenclature name and the systematic one. It's very simple because we don't have a subindex here, any number. So, as we know, last name will be oxide, and then the name of the element, magnesium. Really simple, magnesium oxide. Okay, good. Here, the same number, same name as the stock, magnesium oxide, magnesium oxide. Why we don't use any Roman name? Because magnesium can only have one oxidation number, which is exactly +2, and oxide is -2. Yes, so because they only can have these 2 oxidation numbers, we don't need to write it down. It's supposed that the reader already know these oxidation numbers. And why we don't have here a 2? We don't have here a 2 or a 2. Why? Because we divided by 2. We divided by the same number, by 2. So we don't write it. Okay? Next, we have this P2O5. This is phosphorus and oxygen. Okay, how we call it? D phosphorus, and this 5 means that we need to write penta. Okay, penta. So D phosphorus, penta oxide. D phosphorus, pentaoxide. Yes. And here we have the most complex one, because we need to know the oxidation number of phosphorus. Okay, we have P2O5. So what's the oxidation number of P2? Is plus 5, comes from this number. And what's the oxidation number of oxygen? 2. Okay, so now because there are 5 oxygens, the number of the oxidation number of phosphorus will be 5. So you need to remember which elements have more than one oxidation number. In this case, phosphorus is in the column 15 under the nitrogen, and it has 2, 8, and 5 as an oxidation number, possible oxidation numbers. Phosphorus. Okay. Selenium and oxygen. This next exercise. So selenium trioxide. That's what we have. Trioxide. Okay. This is what we had. Trioxide, selenium trioxide. So we have 1 selenium and 3 oxygens. What's the oxidation number of the selenium? Will be 3 oxide. Maybe we will check this out. This is a really tricky one. Will be the last and the most tricky one, because here, as you can see, selenium is under sulfur, oxygen is in the column 16, oxygen, sulfur, and selenium. Okay, selenium has 2, 8, and 18, and 6 as an oxidation number. In this case is 6. Yeah, it could be 2, could be 8 or 18 or whatever. Yes, but we're going to guess which number are we going to put here according to the formulas given in the stock. We can obtain, we can have this as a very beginning, selenium oxide, and then we have to guess the 2 names, or like in this case, we can get the stock name and then find out the formula or the systematic name. Okay, good. So we have selenium 6 oxide. Okay, selenium and then 3 oxygens. So since we have here oxidation number -2, the question is, why is not there? Why is not here? Probably because we have, probably not, is that way. We divided by 2 already. Okay, so the original sentence will be, we have a 1 here, yes, because we divided, we don't write about it. So we have to multiply by 2 to get the original formula. So 2 multiplied by 1 is 2, and 2 multiplied by 3 is 6. Now we have the oxidation number of the selenium. Very easy. When we write the original formula and we realize that the selenium has not a 2 by its size, is a 1, is because we divided the original formula, this one, we divided the original formula by 2. This is the original formula. We divided the original formula by 2 and then we obtained this. Okay, how we realize that this formula, simplified formula, is not the original one, because we cannot find here close to the selenium a 2. Because we don't have a 2 here, we have to guess, oh my god, there is no 2 here, is because it was divided by 2. So here we have the 2 and here we have the 6. This is the original one. And then we divided by 2. Okay, that's it. Very good, nice and smooth. Now that we know that we have to write selenium 6 oxide, this exercise is done. Let's go to the next. Here we're talking about hydrides. Okay, very easy, this one's too. All of them compounds finish in hydride, 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 and hydride. Okay, in the stock and the in systematic one, hydride, 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 and hydride. We don't use, in this case, we don't use prefixes, but here we are going to use prefixes. Really, these names save our asses sometimes. Okay, so what we have here is this, these two. They give us these two in gold and bold, and then we have to guess the rest of the formulas or the rest of the names of the stock. Okay, I'm going to erase this to make it more clear. Good. So since we have this this formula, it's easy to get the stock because we just need to say the name of the element, gold, and then 3 hydride, okay, hydride. Quitamos la S, so we erase this S, and we will have the final name of the stock and the systematic name. Good. Gold 3 hydride, okay, because we have 3 hydrogens, that's why we use the prefix 3. We don't use prefixes here, we use oxidation numbers in brackets, okay? As we say, this 3 is because gold has 3 as an oxidation number. I will write it here, okay? Sorry, I will write it better, smoother, okay? Oh, here. Okay, good. So we use here 3, and here it will be a 1. I will write it with this. Will be a 1 here. but we don't write it. We don't write it. So oxidation numbers will be 3 in this case, and here will be a -1. So gold has a lot of oxidation numbers, but because it's close to the hydrate and is the only possible um, mm, possibility for the gold to have this oxidation number, because it goes here. Yes, so that's why we need to write 3 hydrate, and the oxidation number we need to put between brackets in Roman numbers is 3 by gold. Next, sodium hydrate. Sodium has only one oxidation number, that is +1, and the hydrate, the hydrogen will be -1, so 1, 1, we don't write it. We don't write a 1. It's gone. It's gone. Okay, it's gone. So here, lucky you is the same. Here, systematic and stock names. Okay, good. We have aluminium. Aluminium. We have aluminium hydride. We have aluminium hydride, and is the only aluminium hydride possible. Okay, there is no other possibility. So aluminium is only going to be mixed with hydrogen in this form. Okay, so we need to bear in mind and memorize this by heart. Okay, so aluminium, 3 hydride, okay? And because aluminium is the only way to fixed to be without hydrogen, this is the only possibility. Okay, aluminium has oxidation numbers 2, 3, and 8. Okay, in this case, aluminium 3 hydrate is having 3 as an oxidation number. It comes from here. Okay, this is +1 or -1. In this case, -1. So aluminium has 2, 8, and 3 as possible, but when it meets the hydrogen, aluminium, it has only 3 as an oxidation number. Is it clear? Good. Okay, no 2, no 8, only 3. Okay, good. So next, lead dihydrate. Lead dihydrate, because we have 2 hydrates, dihydrate, and PbH2, these 2 comes from the oxidation number of lead, that is here 2. Okay, very easy. Magnesium hydride, we have this name, magnesium hydride. So magnesium is in the second column. As you might remember, the oxidation number of magnesium in the second column, alkalinoterreos, earth alkali, have only 2 as an oxidation number. We have only this number, so we don't write here between brackets 2. We don't write that. Okay, we don't write that. Okay, we don't write that. Okay, we don't write that because magnesium has only one oxidation number, which is +2. That's why we write 2 besides the hydrogen. Okay? Oh, sorry, in this case, it's the same. Okay, good. Magnesium has only 2 as an oxidation number. That's why we don't put it here. Why we put it here 2 in lead? Because lead has more oxidation number. So the reader must know that in this case lead has 2 as an oxidation number. Okay, good. Last one in this page, we have this as an original information: iron 3, and hydrogen, as always in this case, is -1. We swift, we put a 1 here and a 3 here, but we don't write it. This one is not needed. So we have now the formula. Okay, is this, and then we just make our mind up and iron 3 hydride, and that's it. Easy and simple. Next, we have these elements. We have this information, we have this information, we have this information, and we have this information. Okay, this column is the commercial and acid names of non-metallic or semi-metallic hydrides. Okay, good. We're talking about the 16th and the 17th column. Okay, so these are the halogen, which is fluorine, chlorine, bromine, iodine. Yes, so fluor and chlorine are from the same group. Fluor, chlorine, bromine is not here, iodine is not here. Okay, and then we have this is group 17, and this one is group 17 too. Yes, so the rest of them will be group 16. Okay, and group in this case is boron, that is group 13. We have sulfur, that is group 16. We have carbon, that is group 14. And we have tellurium, that is group 16. Okay, so apart from these two groups, these two examples, chlorine and fluorine, that is here, gives me this information. Yes, these one are different. Okay, yeah, good. These two are different. I must say. 16 and 17. Yes, they're different because group 13 and 14 and 15, they have commercial names. Commercial. Yes, commercial are these ones: borane and methane. Okay, borane and methane. I will remind you with the PowerPoint presentation. Okay, so here we have the acids. Do you remember? Yes, I'm sure you remember. We have acid, acid, and acid. Yeah. And this group 16 and 17. But the rest of them have commercial names. They have commercial names: ammonia, phosphane, water, borane, methane, silane. Okay, from group 13 and 14, yes? And 15 too, yes? Ammonia, phosphane, and water, yes? So coming back to the previous thing, we have 13, 14, 15. There isn't any examples of group 15, but it will be the same commercial name like the ammonia. Yes, ammonia. Good. So in this example will be hydrofluoric acid. Yes, group 17 and group 16 have acid names. Yes, acids. They are like acids. Acids, 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 acids. Okay. So hydrogen fluoride, boron, in this case, boron 3 hydride. As you can see here, we write hydride. Okay, in the group 13 and 14, hydride. Yes, but group 17 and 16 are different. Okay, we don't use hydride, we use the chloride at the end. We put hydrogen at the beginning. Yes, because here is at the beginning. Okay, is at the beginning, is at the beginning, and is at the beginning. Yeah. So they tell me this. If I don't remember group 17 or group 16 or group wherever, I just see in this case that hydrogen is in the beginning. So it's hydrogen and then fluoride. Yes, hydrogen and then fluoride. And then we have to name the acid. And we put hydrofluoric acid. Okay, hydrofluoric acid. Okay, good. Next, they tell me borane. Okay, it's not an acid, so will be first of all the borane and then the hydrogen. Yes, because in this case it will be the other way around. First hydrogen and then the fluorine. Yes. So when we get this example, for example, this name, I will know that the first element I have to write is hydrogen. Yes, and then fluor. Yeah. Good. Hydrogen fluoric acid, in this case boron, and then hydrogen. Yes, so I write it down, boron H, and now I have to guess what's the oxidation number of boron. Okay, it always has 2 and 3, but what I know is that hydrogen has always -1. Yeah, so here could be 3 or 2 because boron has 2 and 3. Okay, but borane is really a specific compound. it always goes with 3. Okay, so boron when meet the hydrogen is always +3, and hydrogen -1, always. Boron and hydrogen, boron always has +3 and hydrogen -1. That's why we write a 1 here that we don't write it, and then we write it here a 3. Yes, so we have the formula. Good. Um, let's check how the next exercise, well, 3, yeah, boron 3 hydride, yeah. Next is, they tell me that it's an acid, so first of all will be the H, and then the chlorine, yes, hydrochloric acid. I know that is -1, and chlorine always have 2, 8, or whatever. In this case, chlorine has, in this case, has +1, yes, chlorine. So it will be that way, hydrogen, chlorine. We have to remember by heart. Okay, good. Next, they tell me the formula. So very easy, dihydrogen sulfide, and hydrosulfuric acid. Hydrosulfuric acid. Yes, very simple. Okay, sulfur in this case has 2 as an oxidation number. Next example, they gave me this, which meant that there is a carbon first and hydrogen later, hydride, tetrahydride, and then the commercial name, yes, the commercial name, methane. And then the last one is hydrogen telluride. This is what we have as information from the beginning. So we have a nitrogen first, and then telluride, tellurium, yes, hydrogen and tellurium. Good. The tellurium has a lot of oxidation numbers, but when it meets the tellurium as always +1, +2, and this is -1, so H2 tellurium. Yeah, hydrogen telluride, So there is an important information here. Why is not dihydrogen telluride? Why is not hydrogen telluride? Because this is the only possibility of the tellurium to meet the hydrogen. It's the only. There is no other option. So always you can, when we put hydrogen and tellurium together, tellurium never will have any other oxidation number. Always +2. Not 8 or 6, no. Only 2. Okay? This is the only way of find tellurium with hydrogen. So this is the only possibility to have the tellurium with the hydrogen. No other option. No other. Okay. So hydrotelluric acid. Yes, like in here. sorry, hydrotelluric acid, it will be hydrotelluric acid. I'm gonna see it. Hydrotelluric acid. Here, hydrotelluric acid. As I said, this not the hydrogen telluride, because this is the only hydride of the tellurium that exists, no other option. Okay, so thank you for watching. I hope you had all the information clear. Thank you very much. See you later.